always mean that you have to take it out of every single term. Equivalent can also mean if you simplify as well, you still get the equivalent. So the top I can take out 2 and an x, and I'm left with x minus 4. Nope, I'm left with x minus 2. And then on the bottom, so that's 2 next in the brackets, and then the bottom you get the square. So x plus 2, x minus 2. We don't take non-principal values, they've already saved them for us, which is nice. So I say, what can I take out of the top and the bottom? The x minus 2. I can't take this 2 out for this 2. I can't take this x out for this x. This is an x plus 2. It's attached. The only way it's going anywhere is if I have an x plus 2 on top, which I do not have the numerator. So it's staying. So I'm left with 2x over x plus 2, which is 1 mark. Every question got 1, so the whole thing will be on. Which of the following expressions is equivalent to that? So here we're getting an answer, technically, from the question. So you can work each one of these down, or you can work your way back. Now, if I have negative x times negative 5 over 3, what I have to do is multiply by 3 both sides, and then I have 3x can equal negative 5, and then add 5. So I get 3x plus 5 can equal 0. So that would have to be my denominator. We already have that. If x can't equal 0, that would mean x would have to be my denominator as well, right? And then if I have x can't equal 5/3, same thing, multiply by 3. 3x can't equal 5. Subtract 5. 3x minus 5 can't equal 0. That would be my denominator. So I know I'm going to have 3x plus 5, x and 3x minus 5 in my denominator, which is all of it, right? And then I have a 5 on the top, because I already have a 5. So all of them have that. The catch, though, is that at the end, I only have 3x plus 5 left over, right? So I need to get the x to go away, and the 3x minus 5 to go away. So I need to have one that has an x on the top, and the 3x minus 5. So it's going to be a. Okay, this is going to cancel this off. This is going to cancel this off. And I'm left with 5 over 3x. That's 1 mark. Let's look over. So then I have Penman error in the simplification of the rational expression. Got 2x plus 7. 2x plus 7. 2x plus 7 over 2x squared minus 50. What are you making here? So we took a 2 out, left with x plus 5. Took a 2 out, was left with x squared minus 25. Okay? Cancel these off, and he's left with 1. That seems sound, right? Good. The best way to do these is try and work through the way they did it and see if it makes sense. Okay? Now I'm left with a 1 and a 1, and they did different squares to the denominator, which is good. Then here I have an x plus 5, an x plus 5, and an x minus 5, right? So they canceled these off, they canceled off the 1s, and they said I'm left with x minus 5. What did I tell you when you completely cancel off the top? What's left there? A 1. So this step is actually wrong. They should have a 1 over x minus 5. If the 1 is in the denominator, it can go away. If the 1 is in the numerator, it has to stay. Hey. I don't know how to do that. I just made that up. All right. So, it's x minus 5 on the bottom. Has to stay on the bottom of 1. If you think this is actually the same as that, you're telling me that a quarter is equal to 4. Is that true? No. So x minus 5 is not equal to 1 over x minus 5. That's the same thing. A quarter is equal to 4. It's not true. Neither is that. So the error is step 4, which is D. 1 mark. Then we have an equivalent form of this expression. 12x squared minus 6x cubed over 4x cubed minus 2x squared, where x can't equal 0 and 2 is. Now, like I told you, all of these are all old diploma questions or ones they've given us to give you guys a try. So we practice diploma style questions all the time. So it's not like you get to the test and that's the first time you see diploma style questions. Okay? So here we take out a 6 and an x squared as a GCF. So 6 by itself, the x squared by itself. And then to a 12x squared divided by 6x squared, we're left with a 2. Minus 6x cubed divided by 6x squared, we're just left with an x. Over. The denominator is together 2 and an x cubed. But because we just multiply, I just put it in their own bracket. 4x cubed divided by 2x cubed is 2. Minus 2x4 divided by 2x3 is just that. I have x tends equals 0, which is true. Remember, if it's an x squared, x cubed, x4, x7, any of those by themselves, it's just 0, because this would be x times x times x, so you technically get 3 non-principal values of x tends equals 0. But we only write it. And then this one, when we solve it, would be 2 can't equal x, because we have 2 minus x can't equal 0. Add the x over it. That's the way to do this one. We get 2 can't equal x. That's how you get those non-principal values. Now, the 2 minus x match completely, so they cancel out. 6 divided by 2, I can take out a 2, so 2 divided by 2 is a 1. 6 divided by 2 is 3. Now here I have x and x, and then down here I have x times x times x, technically. So 1x can cross off 1x, 1x can cross off 1x, and I'm actually just left with an x, right? So in the top, I'm left with a 3, and in the denominator, I'm left with a 2. So 3 over x. Make yourself a mark. So, multiplying and dividing. What do? We factor GCF numerators to denominators. Exactly the same thing as we did with simplifying. Okay? 2, identify NPVs. Exactly the same thing we did with simplifying. 3, cancel out common terms. Exactly the same thing we did with simplifying. And then in the end, you just multiply what's left in the numerators together, multiply what's left in the denominator. So it's basically simplifying with that one extra step. That's it. You have to state non-principal values for the left denominator and the right denominator because you state non-principal values for anything that can be in the denominator. So, if we look at the denominators, we state anything that x can't be in the denominator. Okay, so simplify the following. It still says simplify, but we're multiplying. It'll still say simplify, but we'll be dividing. It'll still say simplify, but we'll be adding or subtracting. How do you know? By the sign that's in between your fractions. Okay? Good. Let's look at these and see what we can do. All right, so we have x plus 1. Can I do anything to that? Just for brackets, that's all I can do. So our first step, just like simplifying, sorry. We do the GCF and different squares of the numerators and the denominators. So the bottom left denominator, x plus 3, not do anything to that. So I would write it as x plus 3, and I put brackets around it because they're attached by a plus sign. Top right numerator, I can take out a what? 2. Take a 2 out of 2x, and I'm left with an x. Take a 2 out of plus 6, and I'm left with a plus 3. And I put the 2 in brackets as well. Because it's multiplied, right? So basically, we're going to show multiplication with brackets instead of multiplication times dots, right? That's all we're doing with brackets. Anything that's multiplied together, we put brackets. Multiplying, 2 brackets aside, going to show the being multiplied. The right-hand denominator, what can I take out? An x. And then x squared divided by x, I'm left with x. Plus x divided by x, I'm left with what? Plus 1. It doesn't just go away. Remember how I kept repeating that? That is where the errors happen. It's right here. People don't put the plus 1. It makes a big difference, okay? So please put the plus 1. Now some people are like, oh great, I can cancel. No, we don't cancel until we see our non-permissible values. How many non-permissible values am I going to have? 1, 2, 3. The number of separate brackets you have in the denominator is how many NPVs you're going to have, unless the bracket contains just a number like 3 or 4, because those are teaching non-permissible values. So our NPVs, remember, if you don't know how to find them, please come in, because I don't have the time to show you every single time how to find them. Because now we're not working on NPVs, we're working on multiplying and dividing. X can't equal -3 for this one. 0 for that one, negative 1 for this one. Please, if you still don't get non-commensurate values, I'm going to get help. Okay? So, now, anything that matches, anything in the numerator that matches anything in either denominator, I can cancel. You go across multiplication sign, doesn't matter. Okay? So I have an x plus 1 in the numerator, I have an x plus 1 in the denominator, so they can cancel. Like I said, it doesn't matter if they're cross multiplication signs as long as they're in the top and the bottom somewhere and they match and cross. X plus 3 here, x plus 3 here, cancel. Then I'm left with a 2 in the numerator and an x in the denominator. Can go away from there? No. So we did all the same stuff simplified, right? Now all we do is anything that's left along the top is multiplied. So 1 times 2 times 1, because you calculate, you're actually left with a 1, right? 1 times 2 times 1 is just 2 in the numerator. 1 times x times 1 is just x in the denominator. And if I want to follow behind, I can say x can equal negative 3, 0, negative 1. You see how if you can simplify, this isn't hard? Same thing, right? That's why I push simplifying so much. So B, 12x cubed. Can I take anything out of 12x cubed? No. Are they attached by plus or minus sign? No. So they can go in their own bracket. 12x cubed. That's a cube, right? That's a cube. 3x squared plus 6x in the denominator. What can I think of as 3x squared plus 6x? And 3 as an x, right? And then I'm left with 3x squared divided by 3x, I'm left with an x, plus 6x divided by 3x, I'm left with a 2. What am I forgetting to do right now? What helps me? If you don't remember, it's not the end of the world, but it helps you if you do remember. With that 3 and that x, what should I do? Brackets around each of them separately because they're multiplied together. I promise you, if you put brackets around each separately, you will have much better success at simplifying. In the numerator on the top right hand side, 4x cubed plus 8x squared. 4x cubed plus 8x squared. What can I take out? 4x squared. 4x cubed divided by 4x squared. I left with an x. Plus 8x squared divided by 4x squared. 2. And this 4 and this x squared can hold their own brackets because they're multiplied. And then I just got 5. And its own bracket. How many non-divisible values am I going to get? 2, because only 2 of the brackets actually have variables in them, right? 3 can't be 0, 5 can't be 0, so only the x and the x plus 2 are going to get me non-divisible values of restriction. This x gives me x can't equal 0. And this one gives me x can't equal negative 2. So those are my non-divisible values. What can I cross off? What can I cancel now that I've seen the non-divisible values? Jen, in here and Martha? X plus 2, anything else? One x on top. Does it matter if you got the x cubed or the x squared? No. So, but it does matter that you can only take 1 for 1. So I can't take this x out of this one and this one. I can literally only take 1 x out. On the top, I technically have 5 x's, right? X cubed times x squared is 5 x's. So I have an x and an x and an x and an x and an x. So I have 5 x's total. I can only take 1 for 1. So I can take one of these x's out of all the 5. So it doesn't matter. If I take it out of the x cubed, I'm left with an x squared. If I take it out of the x squared, I'm left with an x1. But I can only take it out of one of them. Okay? That's where the error comes from. Take it out of both. Can't. I have 5 x's total on the top. I have 1 x total on the bottom. So I can only take 1 out. Does that make sense? People take it out of both. You can't do that. So I'm going to take it out of this one just because it's this. I'm left with an x squared here. So technically, I'm left with 4 x's here. I took 1 out. Makes sense. Okay? I can take a 3 out of the 12 and the 3. 3 divided by 3 is 1. 12 divided by 3 is 4. On the bottom, I have a 5. That's all that's left in the denominator. Can I take a 5 out of anything up there? look like it. So let's see what I have left over. Sometimes you find out in the next step you still could simplify more. That's okay. There's nothing wrong with that if you don't take out all of the biggest stuff right away. So I'm multiplying. I'm going to go 4 times 4 is 16. X squared times x squared is x to the 4. Because technically I have 2 x's and 2 x's, which is x to the 4. You always add them. I know you can all finally walk out here, but you always add them. So this is like I have 2 x's and 2 x's. Over 5. If you wanted to, you follow behind this, x can equal 0 negative. You try C and your turn, please. You try it. So you can take out a 2x squared. 2x cubed divided by 2x squared, you're left with an x. Negative 4x squared divided by 2x squared, you're left with a negative 2. On the bottom, you can take out a 3 and an x. You take a 3x and a 3x squared, you're left with x minus 3. And you can go back to the bracket times x squared. The denominator is the difference of squares. X plus 2x minus 2. Often I find that people can't simplify because they forget about the difference of squares. Okay, so don't forget about this. So I'm going to have x count equal 0, 3, negative 2, and 2. This is what we're getting. So my non-cancelable values are going to be x count equal 0, 3, negative 2, 2. 0, 3, plus or minus 2. I'm going to write that does not look like it. That's a plus or minus. Just getting one. Okay. Plus or minus 2. So what can I cancel? The x minus 2. I can only cancel the statement of these and I have. This x, you take off one of these. And what's the worst case scenario here? You try and make it even more simple and it's not. And don't try, like you're like, it can't be this much. There must be less. It must simplify more. It doesn't sometimes. Don't try and make it. Okay? This x can't cross off this x. This x can't cross off this x. You can't take this 2 with this 2. You can't do any crazy simplifying. That's as good as you get. So on the top, I'm left with a 2. And then an x1 and an x squared. That's 1x and 2 more x's, right? 5, 3, technically, x cubed. Because you could write this as x, and this is x and x. So that's actually 3 x's, right? That's how I get the x cubed. And on the bottom, 3, x minus 3 still there, x plus 2 still there. Doesn't get any nicer. That is it. That is all. Don't try to make it prettier. And if you wanted to, you could say x can equal 0, 3, plus or minus 2. Okay? Try this one if you haven't. Okay, this one, the top left, I can take 2x out, and 2x squared divided by 2x is x. 12x divided by 2x is minus 6. And do an x in bracket. 15x in the denominator, so 15 is x. Times 5x in the numerator, so 5 times x. And then the x minus 6 is go to bracket. Now, I know people get excited because you can see stuff that can cancel, which is good. But don't forget to state your non-permissible values first, your restrictions. So this one doesn't have restrictions, 15. This one is x can equal 0, and this one would be x can equal 6. 6 minus 6 is 0. So our non-permissible values are x can equal 0 or 6. And I can count. So, x minus 6 is cancel. Remember, it doesn't matter if it's on the top or left and the bottom right. You can still cross off as long as it's on the top and the bottom. If you have like an x minus 6 on the top up here and an x minus 6 on the top up here, they're both staying. Okay, you can't cross them off. Some people try and do that. You can't. It has to be in the one in the top and one in the bottom. This x cancels off this x, or you could have done this x canceling off this x. But it's 1 for 1, right? So you can't go like 1x on the bottom and 2x's on the top. Okay, it's 1 for 1. So I counted this one, but you could have crossed this one off and kept this one, it doesn't matter. And then the 15 and 5, so 5 divided by 5 is 1, 15 divided by 5 is 3. And then left with 2 times 1 times 1 times 1 times x, so 2x. Right? 2x over 3 times 1 times 1 times 1, so 3. And I always check 2x over 3. Can I take anything out of that? No. Sometimes like you just miss something and that's fine, and you'll check on here that you'll see on here, oh, I still have to divide out, whatever. And do that. Fine. X can equal 0. And flip over. With the appropriate restrictions, the product 2x minus 24 over 3x squared minus 12 times, when they're just brackets inside each other times, right? Multiplication. 6x plus 12 over 2 reduces to a whole number. Whole numbers are the numbers 0 inclusive positive, right? So 0, 1, 2, 3, 4. Think of the natural numbers and the natural ones that a kid counts. A kid doesn't normally start out at 0, 1, 2. I don't think toddlers going 0, 1, 2, 3, 4. So natural numbers are like 1, 2, 3, 4. Natural ones count. Whole numbers are natural numbers plus 0. So this could be an answer of 0 all the way to whatever, right? It's a whole number. K. The value of K is blank. Always remember to fill in mark response boxes from left to right, and you do not have to fill in all the boxes. So if you get 2, your answer would be 2, not 2.00. It's 2. Okay? Try that. All right. So 12x minus 24, I can take out a 12. And I'm left with x minus 2. Well, painful bracket. 3x squared minus 12, I can take out a 3. And then I'm left with x squared minus 4. What's x squared minus 4? This is the squares. So I'm actually left with 3x plus 2, x minus 2. Times a 6. And then I'm left with x plus 2 over 2. So, x plus 2, NPV is negative 2, this is positive 2. It just says with the appropriate restrictions, so there's no point you have to fill the restrictions. Right? So, we have x plus 2, x plus 2, x minus 2, x minus 2. 6 divided by 2 I'm going to do. Then 6 and 3 doesn't matter. 6 divided by 2 is 3, 2 divided by 2 is 1. 12 and 3 I can take out 3. 12 divided by 3 is 4. 3 divided by 3 is 1. You could have done 6 and 3 and 12 and 2. It doesn't matter. So just take it out. 4 times 1 times 1 times 3 times 1 times 1 is 12. Over 1 times 1 times 1 times 1 times 1 times 1, which is just 12. Your answer should be 1, 2. No more boxes filled in. Always from left to right. Okay. I'm going to give you some homework to work on the multiplication. Questions on your textbook. Division is basically multiplication with one extra step. Step, flip, and multiply. Remember how you did that? So teach how to flip your kids. So I'm saying invert and